Alright, we are on our last quadrilateral. So this is almost the last video of the unit. So we're going to start with going over the properties. So a rhombus really looks like a parallelogram. And in fact, that is going to be the first property that we're going to write down, is that it has all the same properties as a parallelogram. So that's kind of easy to see because it's clearly a parallelogram. So the only difference here between a rhombus and a parallelogram, the biggest difference, is that a rhombus is a perfect parallelogram. And when I mean perfect, I mean that all the sides are equal on the outside, not just the opposites, all of them. So that's what sets it apart from a parallelogram. All sides are congruent. And it's also very similar to a square because remember, a square has all sides equal. But the difference is that a rhombus doesn't have right angles in each of these corners. They're a little different. However, they do have diagonals that are perpendicular. So if I draw diagonals in here, they're going to make 90 degrees on the inside just like a square. So we'll write down for property number 3 that the diagonals are perpendicular. And so really what the difference between a rhombus and a square is just the corners being 90 degrees. Everything else is the same. There is one more property that's going to help us figure out the angles on the inside, because remember, we can always throw an angle in there and then try to figure out all the rest of them. So let's say that I put that this corner angle is 50. And what's unique about a rhombus is that not only do the diagonals form right angles, but the diagonals also bisect each corner. So do you remember that bisect means to cut in half? So that means that if this angle was cut in half by the diagonal, it's got to be 50 on the other side. So that's what's unique about the rhombus, is that the diagonals bisect the corner angles. So I can also give you just one number in a rhombus and you should be able to fill in all the rest. And we'll practice that next. So now, because we know that the middle is 90, and I gave you that these two corners here split in half are 50-50, it's still the same as a parallelogram in that opposites are equal. So that means over here in the opposite corner, these are both going to be 50. So any ideas on how we can get the other diagonal over here? How could we get this angle over here? Hopefully you're saying to yourself, I remember we've been doing this for a long time, and that I have a triangle here, and this triangle has to equal 180. So if I know that I have 90 in the corner and I have 50, 90 plus 50 is 140, so I'd subtract 140 and I would get 40. So that means that all the rest of these have to be 40. So look what we got here. We got 4 equal triangles. So if you find one triangle, all the rest of them are going to be the same. That's pretty easy. That's pretty neat. So let's try one of these by ourselves. So I'm going to draw an example for you. And if you want to pause it, I'll give you a few minutes. You can try to figure out if you could fill in all the corners. So all I'm going to give you, actually every single angle you should be able to fill in. So I'm going to give you that this corner up here is 20. And so on a test, what I would expect you to do is be able to fill in all these angles, and I'm putting dots around. You should be able to fill in all those if I just tell you that this is 20 and this is a rhombus. If you want to hit pause, you can. So hopefully you remembered the property that said that the diagonals bisect the corner angles. So if the diagonals bisect, that means that the one right next to the 20 is also going to be 20. And then the rules that the opposites are congruent are going to tell us that all the other ones over here are also 20. Woo woo. Then, remember I told you that the diagonals also are perpendicular. So that means every single angle here in the middle is 90. Now you could write 90 in, or you can draw the boxes like I did before. It doesn't matter. Same diff. And then now we need to figure out what these other 4 missing angles are. They're going to be the same. Now we have to use the rules of a triangle, and we know that every single triangle in here has to equal 180. So 90 plus 20 is going to give me 110, and I'll subtract 110 from 180 and I'll get 70. So that means every single corner that's left is going to be 70. I have 4 equal triangles and I am set. So hopefully you'll be able to do that again in class. Alright, now I'm not going to show any more examples because every other example that I could give you is going to talk about everything that we've done already. Linear pairs, opposites are equal, alternate interiors, part plus part, etc. So I'm going to skip all that and we're going to go right to the area because this is really the only new information. So the area for a rhombus is using the formula 1/2 d1 times d2. Now the d stands for the diagonal. And so when I mean diagonal, I'm talking about this guy right here and then the other guy right here. Now what they're going to do in a rhombus is that they're not going to give you the whole diagonal. So this 14 is only represented from this corner to the middle. And remember, in any of the quadrilaterals, the diagonals are going to bisect. So if this half is 14, the other half has to be 14. So when you plug in the diagonal, this diagonal has to be the whole diagonal, meaning from corner to corner. So when you plug it in, you'll go 1/2, and then the whole diagonal, the green one, is going to be 28. And then in the other one, we're going to get 10 and 10. So you're going to have the other diagonal being 20. And so then what you do is just go ahead and plug her in. So you would get 1/2 times 28 times 20, which would give you 280. And that's how you figure out the rhombus area. Now, you know I'm going to throw you a little curveball. It's always not that quite easy. So I'm going to show you where they could try to, mess you up. So let's say you were given a rhombus, and this is rhombus crap. If you notice, this is supposed to be a P. So rhombus crap. And I'm going to throw some values in here. So let's say that from C to S, I know that my value is 8. And then R to A is equal to 10. So let's write down the formula. Area equals 1/2 d1 times d2. Now you don't have to write the 1 and the 2. You can just do dd. That's fine. Just wanted you to know that that means the two different diagonals. So we know right here that the other side of this guy over here, SA, is going to be equal to 8. So that means we know that one of the diagonals, C to A, is going to be 16. So we could go ahead and plug that in as 16. But what is the other diagonal equal to? From R to P. I don't have any information on that. So what in the hizzle am I going to do? Well, since we don't have it, we got to figure it out. How can we figure it out, you ask? All of these guys are right angles in here. So you guessed it. We have a right triangle, and we're going to do that good old-fashioned Pythagorean theorem. This guy is going to come back to haunt you. We've done this so much, you should be pros at it by now. Now, what I want you to make sure you know, though, is that the 10 represents your hypotenuse. So plug that in for C. 8 represents your A or your B, so we'll plug that in for A. And this guy is the one you're trying to find. So this is part of your diagonal. So 8 squared is going to be 64. I'm going to subtract the 64 over here to 100. And that's going to leave me with x squared equals 36. And the square root of x is 6. So that means that this piece, just from R to S, is equal to 6. So that means how much would the whole diagonal be? 12. So now all I have to do is 1/2 times 16 times 12, which is 96. And now you have your area. So hopefully this is helpful and you will be able to finish your worksheets in class tomorrow.